Hello, my lovely students. A very warm welcome to all of you and ICSE 10th class. Your most awaited chapter, Organic Chemistry, is here in front of you. I am doing equal kind of a chapter. It's like chapter is divided in whatever number of sessions. I'm doing it in both the channel, like 19th Hindi channel as well as English channel. So please stay tuned and see all the videos. All videos are equally important and in such a way so that we'll be able to complete your syllabus as it's a bit more than CBSE. So please follow all the videos. Okay students, my name is Anubha, your chemistry master teacher at Vedantu, and let's start. Let's have an awesome chemistry with organic chemistry. Are you all with me in this? Yeah students? Okay. So before going ahead, I just really want to ask that how many of you are facing some academic problems like this, a big list. I know there might be some that is not included. You can always tell me. First of all, ma'am, our doubts are not getting solved. What's the answer for this one? Can we do something? So yes, students, in all our session, you will be not even getting only master teacher, the amazing one, but also an amazing team of class teachers who is totally dedicated to solve your doubts instantly. Okay, and it's like not your 70-80% time is going to get wasted in making notes. After every session, you will download the notes of the session so that you will revise anytime whenever you want, and it's super helpful with including all the important questions also, so that nothing should be missed and you like, I am a master of chemistry now and for all the subjects. Test on every 15 days, assignments after every session, so that you will do different kind of questions and you're like, yeah ma'am, now I'm super clear. Even if a question will come in a twisted way, I'll be able to answer it. And competitive exams preparation, I really wanted to do side by side, but I'm pretty much confused. It's like, will I be able to manage it with my boards, or is like any proper structured courses are there? Yes students, there are some foundation courses side by side. You will be able to prepare for your JEE, NEET, Olympiad, NTSC. Definitely possible. And the best part is, with the choice of your own schedule and with the choice of the language between Hindi and English. So do not miss it. It's very important and your problems definitely can get solved and you'll come out, you'll pass with such a flying colors. 90% will become like a right hand, or what should I say, left hand game for you. And extra bonuses are also there. So it's not like some limited sessions. You will be able to attend unlimited sessions at this platform, unlimited live classes, all micro courses. Micro courses are chapter based courses, crash courses, performance report in every session, that how you're doing throughout the session, personalized attention of your master teachers, also class teachers, and possible with one link, the link that is given by Vedantu 19 channel and pinned by Vedantu 19 channel in the description box. So please do not miss it, and you have to apply a magical code for further discount. What it will be? So after going to the link, this page will come. You have to select your grade, select your target among CBSE, ICSE and Maharashtra board, and then you can click on get subscription and can choose your subscription wisely from 1 month, 3 months and 6 months. Ma'am, which one is best? Every course is equally good students. It's just about the discount that you're going to get, monetary benefit I'll say. So if you'll apply this code AGEPRO on MRP, you can get discount from 20 to 43%. It's like when you go for 1 month, the course which was supposedly for 4,000, then after discount 2,699, you can get in 2,159. For 3 months students, you had to pay 6,999 after discount, but this AGEPRO code will help you to solve 31% on MRP and just have to pay 1866 rupees per month, hardly paying 10 rupees per session. And when I talk about 6 months, the course was for 11,499 for 6 months. And then now it's for 1533 rupees per month. You just have to pay 9199. Isn't it like an awesome opportunity? So choose your course wisely. Just see which one is best for you. and how much time you want to spend like some particular chapter, group of chapters, you can manage accordingly. And this is the code, this is the link, AGEPRO. I hope that's super clear. All right, students, and you know that Vedantu JEE result is out, advanced result I'm talking about, and that was so fantastic, best result among all the online classes. When you see that, see, Vedantu managed to bag so many ranks in AIR rank. I'm talking about JEE Advanced, not Vedantu. It's about students. Students will be able to do that, and Vedantu just help them to do that. So 5 in top 500, 11 in top 1000, 44 in top 2000, 121 in top 5000, and 253 in top 10,000. And these are those beautiful faces in front of you. Definitely possible. It's like if Vedantu is there, definitely you can do it from your home also. So stay tuned for all the courses. Do subscribe to channel, do like the videos, and definitely check out all the courses that I've told you. All right, students. So what will be our learning objectives for this session? What are we going to talk about? We are going to talk about isomerism as well as nomenclature of organic compound. Before that, I have given one video on Hindi channel also where I discuss different type of hydrocarbons and what exactly is organic compound. So please see that video as well. And let's start. Ma'am will teach you nomenclature of organic compound right away and what exactly is isomerism. Keep the Josh high, that's very important. And let's start with the session. Naming of organic compound, first of all, from when it started and which organization did that. Let's talk about that. In early days, the name of compound depend upon the source from which it is obtained. I'll give you the entire list that which compound obtained from which sources, and that's how we used to name it. But then after so long, organic compounds will become more and more. It's like around 10 to 20 million, and it's like getting difficult day by day how to name it. And then they're like, there must be some rules and regulation. All right, so we'll talk about that as well. You know what, how methane gas was get its name? Methane gas was something that's also called as marsh gas. It's like a common name because that was obtained from all those marshy places. Okay, so that is one of the reason for the same, marshy gas. Okay, marsh gas. And when I talk about other compounds, that what exactly are their sources? So this is my methanol, students. Methane, because that's methane derivative, and OH group I told in the last session for ol. And last, we are going to add ol for alcohol. So it will become methanol, and methanol is something we can get by destructive distillation of wood. So that's why we also call it methyl spirit and wood spirit, just because of the source from which I am getting it. Okay, and when I talk about urea, urea is something that get from urine, so that's how it got its name, NH2CO NH2. When I talk about marsh gas, ma'am already told you CH4 because that used to get from all the marshy places. And when I talk about vinegar, vinegar from acetum, and acetum itself means vinegar. Why vinegar? Because this ethanoic acid is used in making vinegar. Oxalic acid from oxalis plant. I think your biology teacher can tell in that detail. Oxalis is a species of plants, and from that oxalic acid can be obtained. So that's how oxalic acid. And C2H2O4. Basically, this is the actual compound in front of you. It's like telling the molecular formula, but we'll discuss in detail as well different type of structure. Formic acid from formica, that means red ant. That's how common name is formic acid, and the formula is HCOOH. Okay, students. So what exactly is this common name? But as I told you, so many compounds, who will talk about common names again and again. So nomenclature started by IUPAC in 1957. Nomenclature means giving name. Who is giving name to all the compounds, organic compounds now? IUPAC, it's like an institution, International Union of Pure and Applied Chemistry. Okay, International Union of Pure and Applied Chemistry. And the union told us there must be a proper format. If you'll follow that, you'll be able to give name to all the compounds. And what is that? That there will be a word root in your naming, word root defines number of carbon, and you'll write it in between. Number of carbon, root word or word root, both is absolutely right, means whatever will be the number of carbon, that is the one that's deciding the long chain, right? So that is the word used for that main backbone, main root, that's your carbon chain. So number of carbons is decided with a proper name by your root word or word root. Suffix is something that's written afterwards, so some suffix afterwards. Prefix, that's something that's written before, so here there will be prefix. Alright, number of carbon, root word. Suffix is of two types, primary and secondary. Primary you will write just after naming number of carbon, and then secondary. In the same way, prefix is also of two types, primary and then secondary. Alright, so this is the entire nomenclature. If you'll keep that in mind, you will be able to give nomenclature to any organic compound. It won't be that difficult. So let's talk about word root, that for different number of carbon, what exactly we use. So for 1 carbon we use eth, for 2 carbon eth. In the chain of organic compound, the number of carbon attached to each other is how much? So 1 meth, 2 eth, 3 prop, but, pent, hex, hept, oct, non, funny, dec, undec, dodec. For 20 we use icos, so icosane. And for 30, triacontain. Triacontain. But you do not need to remember that much. For C100, we use hect also. Okay, so this is like using the right word root by seeing the carbon chain, very much important. Suffix, that's something that we write after my word root or root word, and that's of two types. When I talk about primary suffix, I totally means the nature of carbon-carbon bonding. Okay, so if there is a single bond between your carbon chain, that will be the category alkane of hydrocarbons, and the general formula is CnH2n plus 2. And when I talk about double, and the name, the suffix that is going to end is ane. Okay, so it's like if meth, methane, eth, ethane, prop, propane, and so on. When I talk about double bond, a double bond between your carbon chain, then we end it with ene, that's a suffix. And the class was alkene, having a general formula CnH2n, 2 hydrogen difference from the previous one. Triple bond means using ine in the last, YNE, or triple bond between a long carbon chain that ends with ine, because that belongs from the series alkyne. Homologous series also, you can say that alkyne, and having a general formula CnH2n minus 2. There's only difference of 2 hydrogen. Please keep that in your mind. Alright, and there is a special group R that's not at all, I would say that we write it in the last. That's not something that is called as, we write it after root word, but that's something we should know because we are going to use it. Group R is what? When you have your alkane, if you remove your hydrogen, why we remove our hydrogen? Because some specific atom or group of atom can attach to it. So if you remove an hydrogen, you got CnH2n plus 1. So that was alkane that converted to now alkyl group. Alkane converted to alkyl group having 1 hydrogen less. As 1 hydrogen is less, that means this carbon has to attach to the long chain of carbon, and that specific group is called as alkyl group, and we generally write it by using a symbol R. Okay, so having this as a common formula, alkyl, as of 1 carbon methyl, 2 carbon ethyl, 3 carbon propyl, and so on. Alright, so this is something, this alkyl group is something is attached to my carbon chain, is acting as a prefix. That's something that we give its nomenclature in very starting, and we'll use that and you'll get it properly. And how come when we'll discuss different kind of cases. So let's discuss the systematic nomenclature right now in front of you. So prefix, I already told you what is my prefix. It denotes the substituent alkyl group or functional group in the carbon chain. Generally, my alkyl group act as a prefix, but there's a special functional group also. There are more also, but something that you should know is one only. The functional group, that is halogen. Halogens also act as prefix. Halogens means your member fluorine, chlorine, bromine and iodine. They are also acting as a prefix and having a sound like halo, like the general name that we give as halo. So fluorine will become fluoro, bromine will become bromo, chlorine will become chloro, iodine, ido, and so on. Okay, you got it? So my alkyl group and halogens are the ones that act as prefix. That part is pretty clear. Okay, so let's see that if I'm having this carbon long chain having 5 carbon, you see this group is nothing but an alkyl group following alkyl group formula, CnH2n plus 1, having 1 carbon for 1 carbon meth. So what will I call it? Methyl group. And at what position of carbon 2? So this is 2-methyl. Why second position, ma'am? Why not fourth position? Because when I count it from this side, it's like fourth position. So remember that, students, this carbon chain, long carbon chain, is also called as parent chain. The chain that's having maximum number of carbon and deciding the word root is called as parent chain. And whatever is attaching to parent chain, like your substituent, your functional group, okay, your halogens, these are acting as children for the parent, something that needs more priority. And for more priority means they should deserve lesser number. Okay, so we'll count my carbon chain from that side so that these children, these functional group, these alkyl groups, these halogens should get the minimum possible number when we'll count it. Okay, you can't count in between, you have to count from the edges itself. All right, so you got it. We'll talk about all the rules one by one, and trust me, you'll get it. In naming organic compound, the very first simple formula that the simple rule that you need to know is selection of carbon chain. And which carbon chain you'll select? The one that is going to have maximum number of carbon. Okay, whether you count it from left to right, right to left, top to bottom, whatever it is, it must not be a straight chain only. It could be of any shape. All right, so look at this. Let's see what possibility we are having. 1, 2, 3, 4, 5. Don't say 5 because I can have a better long chain. It's like 1, 2, 3, 4, 5, 6, 7. It's like it must be a continuous chain. There must be no break in between. And you see that this Z type of my chain, I got it having 7 carbon number. So definitely that will be the one that's my parent chain and deciding my word root and nature of carbon. So 7 carbon is going to be hept and single bond between them is ane, that's primary suffix. So that's heptane. Not like the nomenclature is completed. See that my third carbon is having 2 carbon substituent, and 2 carbon substituent is ethyl, if you are forgetting that. Why ethyl? See, this carbon is attaching to 2 bonds. That means this is CH2. This carbon is only making 1 bond, so that's CH3. How come carbon should follow its tetravalency, should make 4 bond? And how come 4 bonds? The rest bond it will make with hydrogen. So this CH2, CH3 is what? Isn't it your ethyl group? CnH2n plus 1 alkyl group? Yeah. So third is having this alkyl group, and you know that act as prefix and should be named in very starting. So it will be 3-ethyl heptane. Now the nomenclature is completed. Are you getting it? Yeah, students, do let me know your response in the comment section and tell me, yes ma'am, we are super ready and we are going to do great, and we are looking forward for all the videos, and yes, we'll do that. All the important chapters. The second rule is the branch chain are considered to the substituent and their position are indicated by the number of carbon atom that they are attached, which ma'am already told you. Whenever I am done and whenever we are done selecting the longest carbon chain, the remaining carbon acting as a branch will be a substituent and should be named in very starting. So do let me know in the comment section what will I call it. I'll leave up to you because the similar way we did it last time. 1, 2, 3, 4, 5 should not be 1, 2, 3, 4, 5 from this side, because from this side 4th position is given to your methyl group, but from left to right 2nd position is given to methyl group. children should get more priority means lesser number. Second number is better than the fourth number. Okay. So let's talk about the next one. The carbon atom of longest chain are numbered in such a way that, as I told you, my alkyl group should get the lowest possible number. So there is no denying in that. Before you'll tell me, I itself told you. Second group is having methyl. So this is 2-methyl. Now done about prefix. Let's hit on word root. Root word 5-carbon pent having single bond is ane. Do not see that, ma'am, hydrogen is not there. You can put it. It's just a simple way to show it. Alright, students. Now, what if there are functional group also and some alkyl group also? How should I give the nomenclature? So do remember it. It's like functional group and alkyl group. Who is the bigger one? Who is the bigger one? That's always your functional group. That's something that acts as a suffix. So do remember, there is one more thing that I'm adding in nomenclature. When I told you word root or root word, whatever you call it, after that I told you suffixes of two type, right? So one is primary and one is secondary. Primary just after word root, and that's ane, ene and ein. We discussed that. The secondary suffix is nothing but functional group. I already made a video last time where we discussed in short on Hindi channel. You can prefer that. Functional group, atom or group of atom which is defining the new chemical properties in your compound. And when you have functional group and then root word, before that we use prefix. Prefix like halogens, prefix like my cyclic group, prefix like my alkyl group. So it's like whenever I'm having my prefix also and I'm having my functional group also, which one should get more priority? So do remember that suffix should get more priority than prefix. Means in the given case, you have an alkyl group which is a prefix, you have an OH group which is alcohol group, a functional group, a suffix. So you have a suffix and a prefix. Which one is preferred? You will prefer functional group first and then alkyl group. So nomenclature will be from which to which side? Right to left side, okay? Right to left side. It's like 1, 2, 3, 4, 5. Right to left side, because in that way my OH group is getting second number and my CH3 is getting fourth number of carbon. But on this side, 1, 2, 3, 4, 5. 2 on methyl, 4 on alcohol. That's not the right way. Suffix should get more priority. So the naming will be, how will I give name? Prefix in very starting, 4-methyl. Why I am writing the position? Because so that will be clear when the name is given to me, I can write the exact structure out of the same. If they'll just write methyl, I'll be like, which carbon I should put methyl? So that's telling fourth carbon is having methyl, and with number and writing the name for it, you will put a hyphen in between. So 4-methyl and then prefix done, 5-carbon pent, single bond ane, and second carbon is having your alcohol, so 2-ol. Okay, so this is 4-methyl pentane 2-ol. Yeah, so in one example we did talk about prefix, word root, ane, ene and ein, also suffix, that's your functional group. And whenever you write functional group, you observe one thing, that the E of alkane, whatever it is, we'll omit it out. And it's like I had pentane plus ol. So there are two functional group, then we omit E, so it will be pentane 2-ol. Remember this part also. Alright, so now you are taking more and more steps towards nomenclature, and you will be more and more clear with so many examples. Now, if different type of substituents are attached to the chain, how will I decide that which one should I prefer more? So alphabetical order should be considered. So among bromine and chlorine, which one will you prefer, students? B comes first, then C. So nomenclature will also be from that side, so that B will get more priority than C. Alright, so I have a 6-member carbon chain. It will be 2-bromo, I told you halogen group, halo sound will come. So 2-bromo, 4-chloro, hexane, hex for 6 carbon, ane for having a single bond between it. Okay, prefix and then Two prefix, basically we have 2 bromo, 4 chloro, hexane, and then hex for 6 carbon, ane for single bond. Do not miss it, very much important. Now, next case, the position of alkyl group are indicated by writing the position and name of the alkyl group just before the name of the parent hydrocarbon, which I already told you. See, different cases we discussed. Let's discuss these two cases. This is acting as prefix and this is also acting as prefix. I'll write in the name very starting with defining the position also. It's like 2-chloropropane, so it's like 2-methyl propane. All right, so we have to mention position for better understanding. And when substituent will repeat, if same substituent is more than 1 times, then we use some Greek prefix like di, tri, tetra, penta, and all. So look at this example. I selected my longest carbon chain having 4 members. There are 2 methyl group, 2 same groups. So rather than writing 1, 2, 3, 4, that my second carbon is having 2 methyl, 2 methyl. As it seems, I can write it together as 2, 2 dimethyl. 2 and 2. 2 times why? Because there are 2 methyl. So 2, 2 dimethyl butane. Alright. Why from left to right side numbering? Because if you'll do it reverse way, my alkyl groups are getting third number. Second number is better than the third number. Got it? So that's how you are giving different naming of nomenclature, and it's very important, and we are going to discuss so many examples so that it will be like going straight here. Alright, otherwise discussing some few cases will not give that clarity. Let's revise everyone. Okay, word root for it is 3 carbon prop, and then suffix we use for single bond, ane, prefix is what? This 2 position having a methyl group. So the name will be prefix in very starting, no gap should be there, and then prop for word root, and then ane as a suffix, primary suffix. It is 2-methyl propane. Very much clear. Let's have one more example. What about alkene and alkyne? So I am having 2 carbon, and on both the carbon there is prefix attached, that's bromo group, right? So word root for 2 carbon eth. Here suffix is ene, if I'm not wrong, because double bond is there. Prefix is what? My one same kind of group is there, so I'll use di, tri and all. 1 and second, first and second carbon dibromo, right? First and second dibromo, 2 bromo is there. So total name will be 1, 2 dibromo ethene. Okay, 1, 2 dibromo ethene. Now it looks simple. This is the right way to write it so that you will never get confused and more clarity will come. Let's discuss one more example. Now you have just 2 carbon, but on these 2 carbon there are 1, 2, 3, 4 chlorine attached. Word root for 2 carbon eth, single bond, so suffix ane. Prefix is your 1 and 2 carbon is having in total 4 chlorine. For 4 we use the Greek symbol tetra and then chloro as 4 chlorine prefix. So name will be 1, 2 tetrachloroethane now. So 1, 2 tetrachloroethane. Is it clear? And not at all difficult. I hope you're getting that kind of feeling. Yes ma'am, now we can do it. Let's discuss more example. 1, 2, 3, 4 carbon chain having a triple bond between it, and then you can write it simply in the condensed formula. This is open structure formula where I'm showing all the bond. Condenses, I'll show the carbon chain and writing all the hydrogen all together. CH3, C, triple bond C, and then CH3. Now that looks a bit, shorter version, but that's the same only. Word root for 4 carbon, that's but. Suffix will be ine now because triple bond is there. Is there any prefix? Not at all. So it's simply, and also this triple bond is attached to second carbon. I'll mention that also. Please do not forget it. That is attached to your triple bond, double bond. If is not attached to the first position of carbon, then I'll mention its position. So otherwise, how will I am sure that it's 1-butene or 2-butene, or butyne or but1-ine. That must be clear. No prefix, so name will be but2-ine. And the naming of double and triple bond you can tell in very starting also, like this, 2-butene. That's also clear. All right, please keep that in mind. Make it a note. All right, yes. One more example. Let's discuss different type of prefix. I have 1, 2, 3, 4, 5, 6 carbon long chain. You see all the possibility, and why I'm counting from right to left side, because in that way my prefix, my alkyl group is getting more priority as it's just getting third number. But if I'll count it from reverse way, it's getting fourth number. Are you got it? Are you able to get it? Okay. So this is hex and then ane, and prefix is 3-methyl. So I hope you're able to write it now. It's 3-methyl hexane. Okay, easy peasy. Let's discuss one more case now. 1, 2, 3, 4, 5, 6 carbon. 3 is having 2-methyl. So what will be the name prefix? That is 3,3-dimethyl. Okay, 2-methyl, same kind of a substituent. 3,3-dimethyl. For 6 carbon hex, for single bond between them ane. So this is 3,3-dimethyl hexane. Right. This one again very easy. I have 1, 2, 3 carbon. If you count it from this side, there will be 2. You will count it from that side so that you will get the maximum carbon. That means longest carbon chain. So when I count 1, 2, 3, I have two kind of a group, methyl and bromine. That's bromo group. So it's like, which one should I write before, methyl or bromo? You know that alphabetical order, B comes first then M. So when you write it, how you'll write it? 2-bromo, 2-methyl. Are you able to get it? Don't write 2,2-bromomethyl, because there must be same number, then only same substituent, then only you can write it together. If no same, you'll write it in this way. 2-bromo, 2-methyl for 3 carbon prop for single bond ane. So this is 2-bromo, 2-methyl propane. Pretty easy. Now let's talk about functional group also. OH is a functional group. Alcohol, secondary suffix, I'll write that all in the very last. So 1, 2, 3. Why I'm counting on this side? I told you, when you have suffix, specifically that functional group, more priority than your prefix, definitely than your alkyl group. So 1 carbon, 2 carbon, 3 carbon. So what will be the name? Prefix is your alkyl group, 2-methyl, then prop for having a chain of 3 carbon, ane for having single bond, ol for functional group ol, and E will be omitted out. So it will be 2-methyl propanol. Okay, 2-methyl propanol. Easy peasy. Okay, let's discuss one more example and then we'll move ahead. Again, 1, 2, 3, 4, why from right to left? Because COOH is by functional group carboxylic acid, your organic acid, that is. Okay, and please do not miss this carbon. Some students are like, this carbon will not be included, and that starts from carbon, and being a part of long carbon chain, that should be counted as well. So now my second position is carrying ethyl group. So 2-ethyl, alkyl group of 2 carbon, 2-ethyl for 4 carbon but, single bond ane, and carboxylic acid ends with oic acid. So name will be 2-ethyl butanoic acid. 2-ethyl butanoic acid. I hope you're pretty much clear with all the cases. Do let me know. Fill the comment section. Yes, ma'am. Getting it? All positive we are? Yes. Now let's talk about what are the different ways to write organic compounds, and why I'm telling you, so that you'll be able to understand isomerism, isomers easily. One way is structural formula, where you will show all the kind of linkage between carbon, hydrogen and whatsoever atoms attached. Okay. You will show all the different elements, how they are linked all together in the molecule. That's what gives structural formula. So C4H10 is your butane. First of all, you will write all the carbon with a single bond between them. Ane means single bond. Then you will write hydrogen with showing all the linkage so that carbon's valency should be satisfied. That's 4. Alright. Now condensed formula is what? Easy way to write it. You write all the carbon and hydrogen, whatever is going to be there on that carbon, you will write it all together. Molecule having the bigger structural formula specifically, we'll do that so cumbersome to write in that, open linkage. So we'll do it in this way, called as condensed formula. Alright. And sometimes it's like easy to show in the carbon skeleton form. For organic chemistry, it's very easy that if nothing we are writing, that means hydrogen will come. Okay, so you can write it in both the way if longer and bigger structure is there. All right. Now let's talk about isomers. It will be very, very easy. What are our isomers, students? Compounds having same molecular formula but different arrangement of atoms with respect to one another and thus form different compound. It's like when I have a fixed chemical formula, suppose I'm talking about C4H10. Alright, first of all, when you read it, it's like butane. So no, students, in organic chemistry, whenever you have same molecular formula, that can be represented with different arrangement of those carbon and hydrogen and can give different kind of a compound having different name for them. So different physical and chemical properties, and they will be called as isomers of each other. So when you write a chemical formula, be aware in organic chemistry that can give you, n number of structure possible, 2, 3, 4, whatever it is. Different kind of structures, different kind of position of your groups given can be there. So you should keep that in mind. And the phenomena of having isomers is called as isomerism, as simple as that. Yeah. So C4H10, if I talk about, students, what I'll tell you, let's discuss with this only. 4 carbon, and first it's like writing 4 carbon in a straight chain, but 4 carbon can be written in this chain also, branch chain. So these two are isomers of each other. See, I wrote it in skeleton form. This is your butane, but this is your 2-methyl propane, right? 2-methyl propane, 2, because your second carbon is having 1 carbon alkyl group, that's methyl, and then propane. 2 different formula, 2 different structure, 2 different kind of a physical properties possible. But it's not just the structure can be written in different way. There are different way of showing isomerism. Not only one. Isomerism itself is of 2 types: structural isomerism and stereoisomerism. So structural is just a part of it, where chain isomers is also there, writing with the different possibility of chain, straight chain, branch chain. Positional isomers, where your alkyl group, where your position of double triple bond that can change in the same formula. Functional group, where having a same chemical formula can be written in more than one functional group. Okay, metamerism, tautomerism, ring chain, some of the types that's not part of your syllabus, but you'll definitely study in higher classes. It's very important. Stereoisomerism, when we talk about the structure of the compound in 3 dimension, that how the atoms are arranged in the space. That's what that is considered. Okay, so that's again not part of your syllabus. You'll get that in 11th and 12th. Okay, so the very important one is this 2, that's part of your syllabus: chain and positional isomers, and very easy also, not at all difficult. Chain isomerism, I already told you, when 2 or more compounds have a similar formula but different arrangement of carbon. Same molecular formula, but I can write it with different possibility of chain, straight chain or branch chain, and these compounds will be chain isomers of each other. Same chemical formula but different arrangement. In what way? Can have straight chain as well as maybe branch chain. So when I talk about pentane, this is common formula. Please see the video that I made on Hindi channel also. Alkenes is having a general formula, CnH2n plus 2. That means your number of hydrogen is double of carbon plus 2. So I can write 5 carbon in what way? One is the straight chain. You can write number of hydrogen. You are mature enough now that just justify the valency of carbon by writing hydrogen. One is straight chain. One is like using carbon in the branching also. So 4 carbon I'm writing on this side, 1 carbon I'm using as a branch. So second possibility. Third possibility, writing 3 carbon in a chain and using 2 carbon as a substituent. 1 carbon as a substituent, 2 carbon as a substituent. I got 3 possible arrangement. So that is chain isomerism, having 3 possibility of making chains. Straight branch with 2 examples, 1 substituent and 2 substituent. This is normal pentane. And students, when your second carbon is having an alkyl group, that's commonly also called as iso. So that is having a common name iso because second carbon is having alkyl group. Pentane because in total 5 carbon. That's not at all IUPAC name. That's a common name. Please do remember and do let me know its IUPAC name in the comment section. Isopentane. And when you're when you're having a carbon that's attaching to 4 carbon, it's like this carbon is quaternary in nature. Quaternary means this carbon is attaching to 4 carbon. If 1 carbon primary, 2 carbon secondary, 3 tertiary, 4 quaternary. So if you're having this kind of a carbon which is somewhat quaternary in nature, we use the term neo for it. Neo and 5 carbon pent and then ane. So this is neopentane. And again, that's also a common name for it. Do let me know its scientific name, IUPAC name in the comment section. It's like your Anubha ma'am. It's like official name. Anu ma'am, and my students also call me AG ma'am. Anubha got short from AG ma'am. So it's like that also common name. So in the same way, scientists also call them as isopentane and neopentane and counting all carbon all together. Different and weird way, but that's absolutely true. Okay, students, let's talk about position isomers also. I think you got it as well. 2 or more compounds having same molecular formula but differ in the position of subsequent atoms, functional group on the carbon atom. If your functional group attached, your double triple bond attached, your alkyl group attached is carrying different position, so they will be positional isomers. So look at this example. I was asked to write, this C4H double minus 2, that's 6. That's the common formula of alkyne. CnH2n minus 2. It's like N is replaced with 4. So C4H6, that's alkyne. 4-membered alkyne, 4 carbon membered alkyne. So not like one possibility, there are 2 possibility. That 4 carbon, I need to mention triple bond. Alkyne is having a triple bond. I have 2 possibility, writing triple bond on this first carbon and writing triple bond on the second carbon. So again, triple bond carrying different position. 1, 2, 3, 4, 1, 2, 3, 4. So this became but 1-ine as triple bond is attached to first carbon. This is but 2-ine, second carbon. Positional isomers of each other. Position of triple bond is changing. In the same way, but2-ene and but1-ene will also be positional isomers of each other. It's like writing double bond at the second carbon or first carbon. These are position isomers of each other. I hope chain isomerism and position isomers is making sense and pretty much clear for you. So you have mastered enough example of nomenclature, so you will be able to do that on your own. Please do not forget this one line, and that is you should know your word root. You should know your word root or root word. You should know your suffix, that's primary and secondary, ane and ine, and secondary as your functional group, as well as your prefix, that's whether halogen is there, whether your alkyl group is there, whether for a cyclic chain, cyclo will be there. Okay, so that's what it is. We did talk about isomerism. That means this session must be super duper clear, and in next session we'll talk about our hydrocarbons, alkane, alkenes and alkynes one by one in detail. Very much important. The syllabus is already reduced, so I will tell you how to approach everything so that you will not lose any marks in this chapter also. So students, I hope you know how to be a part of Vedantu family. Just go and select the link given by Vedantu 19 channel in the description box, pinned by Vedantu 19 channel. Select your grade, CBSE, ICSE, Maharashtra board. Get your subscription now. You have 3 options, 1 month, 3 months and 6 months. It's just about spending more time, you can get more discount. That discount will be achieved if you will apply the coupon code AGEPRO. AG ma'am's code, English channel, Pro is the course. AGEPRO. 20 to 43% you can save after this discount, after this code. So at least give a trial for 1 to 3 months. It will be very much beneficial to you. All right, students, everything is super duper clear. So hope you will like this video, share it to your friends, and tell about this channel that we are doing all the sessions in English language also for you, so that you will not feel any problem in this communication. And hit the like button and hit the bell icon also, so all the videos will come to you. You can reach out to me and do let me know all your response in the comment section. I'll wait for it. Thank you so much for being here. I'll see you next time. Until then, I'm signing it off. Take care of yourself. Bye bye.